All right, in this video, we're going to pick up with the remaining problems on the review sheet for the final exam, and you should already have a copy of the final exam. Okay, if you don't, you might want to speak with the substitute there to get the get a copy of the final exam. Here I'm going to pick up with number 13 and end it with the remaining problems up all the way to problem number 30. Okay. Now, in number 13, we're going to be given the graph of f of x. And here we're going to be making the graph of g of x is equal to f of the quantity x plus 5 and then minus 3. So this is what the graph of f of x is. We need to come up with what g of x is, what the graph of g of x would look like from this particular transformation. Okay? So in this case, there are two different transformations here. Notice the plus 5 next to the x. That tells me I have what they call a horizontal shift. And then that minus 3 here tells me I have a vertical shift. So these are the two transformations that we have in that particular g of x function. Okay? So now, I'm going to create a table down here. This is what f of x is. I'm going to write down what their ordered pairs are. In this case, I have the ordered pairs 3 and 7. The next ordered pair will be 7 and 2. And the next ordered pair was 9 and 5. All right, next. Now I have to figure out which one I'm going to need to do first, either the horizontal or the vertical shift. Well, based on the order of operations, if I take x and add 5 to it, that means I need to do the horizontal shift first. And then I'm going to subtract 3 from it. That means the vertical shift will be done last. If you're in doubt, we always do the vertical shift last, no matter what. Okay, now for the horizontal shift, we have to do the opposite of what's inside the parentheses. It says add 5. The opposite of that would be to subtract 5. So we're going to be subtracting 5 from each x coordinate here. And then I got that minus 3 on the outside. That means I'm going to subtract 3 from each y coordinate because it is a vertical shift. Okay? Anything vertical means the y coordinate will be changing. Anything horizontal means the x coordinate will be changing. Okay? So now, starting with these ordered pairs, we're going to subtract 5 from each of these x coordinates here. So, starting with 3 minus 5, I'm going to get negative 2. Now I'm going to bring over the 7. For this ordered pair, if I do 7 minus 5, that will be 2. And bring over this 2. For this last ordered pair, 9 minus the 5 would be 4. Bring over the 5. Now, I'm going to use these ordered pairs to come up with new ordered pairs after doing the vertical shift. Now, whatever I get in the last column will be the ordered pairs for g of x. So here, the vertical shift means I need to subtract 3 from each y coordinate. So I'm going to bring over the negative 2 for that first ordered pair and do 7 minus 3, which is 4. The next ordered pair, I'm going to bring over that 2. And if I do 2 minus 3, I'm going to get negative 1. This last ordered pair, bring over the 4, do 5 minus 3. That will be 2. This represents the ordered pairs for g of x. Okay, now I'm going to plot those on the coordinate plane here. And those coordinate planes will be provided for you on the exam. So, negative 2, 4 will be to the left 2 and up 4. Negative 2, well, 2, negative 1 will be to the right 2 and down 1. And then 4, 2 will be to the right 4 and up 2. Now I'm going to connect those dots in the same order as the f of x, and this is what g of x looks like. It's the same. The only thing different here is we went to the left 1, 2, 3, 4, 5, and down 1, 2, 3 for each one of those. Okay, that's problem number 13, dealing with the transformations of functions. Now number 14 is the algebra of functions. F plus g, f minus g, f times g, and f divided by g. Here we got two functions, f of x is equal to 3x minus 1 and g of x equal to negative 7x plus 2 in problem number 14. Here we're going to find only f minus g of x. So f minus g of x means f of x minus g of x. So here the f of x is equal to 3x minus 1. And then minus g of x. Notice I'm putting the parentheses around what g of x is because I'm subtracting the entire g of x function from f of x. So I got 3x minus 1 minus the whole quantity of negative 7x plus 2. Now here's what I'm going to do. Bring down the 3x minus 1, this minus sign will change the sign of each term in the parentheses to the opposite. So that minus sign will make the negative 7x a plus 7x. The minus sign makes a plus 2 a minus 2. And then we're going to combine like terms here. 3x plus 7x will be 10x. Negative 1 minus 2 will be minus 3. And that's as far as I would go with that problem. So here, the difference of f and g of x would be 10x minus 3. Okay. So that's problem number 14. Okay, now problem number 15 is the composition of two functions f and g. Here we got f of x equal to 2x plus 5, and g of x is equal to x squared minus 7. And we want to find the composition of f with g of x. Or we can say f circle g of x, as some people want to call it. Now, f circle g of x means this, f of g of x. Here, your g of x is going to be your inside function, as you can see. But g of x is x squared minus 7, so I'm going to substitute g of x with what it's equal to, x squared minus 7. So it's going to be f of x squared minus 7. That's what I'm going to be evaluating. In this case here, that f of x is the 2x plus 5. That's what it's equal to. So here, for each and every x in f of x, I'm going to substitute that x with what g of x is. And here, g of x is at x squared minus 7. So this x will be replaced with x squared minus 7. And in the 2x plus 5, that x will be replaced with what g of x is, x squared minus 7. Now here I'm going to simplify only the right side of this expression here. If I distribute the 2 over the x squared minus 7, this will be 2x squared minus 2 times 7, that's 14, bring down the plus 5, because that's part of the f of x function. Bring down 2x squared. Negative 14 plus 5 will be minus 9. So that means the composition of f with g of x will be 2x squared minus 9. Okay. Here, this is what the composition of two functions is. That's problem number 15. Now, problem number 16 we're going to be decomposing this particular composed function. Here we want to find out the functions f of x and g of x so that the composition of f with g of x is equal to 5 divided by the quantity x squared minus 3x plus 6 raised to the 6th power. Well, let's think about this. This has a numerator and a denominator, so this right here in the denominator could be what g of x is. That denominator, we're going to let that be g of x. That will be x squared minus 3x plus 6, and that quantity will be to the 6th power. Okay? Now to find out what f of x is, this whole thing was substituted for x in f of x. So the f of x function had to start off as 5 over x. So here f of x is 5 divided by x, and g of x is that x squared minus 3x plus 6 quantity raised to the 6. Okay? So that's how we decompose those two functions here. All right, number 17. Here we're going to be finding the inverse of the given function f of x. F of x is equal to 2x minus 6. And we want f inverse of x. So that 4-step procedure starts off like this. I'm going to rewrite the equation or the function. First of all, I'm going to replace f of x with the y. So it'll be y is equal to 2x minus 6. The second step will be to interchange x and y. In other words, this y will be x, and the x becomes y. So the x is equal to 2y minus 6. And then the next step will be to solve this equation for y. Well, I need to move the minus 6 over to where the x is by adding 6 to both sides. So this means I'm going to have x plus 6 equal to y. And to solve for y, I'm multiplying by 2. Let's divide both sides by 2. So that means y is equal to x plus 6 all over 2. So this equation is solved for y. So the final step would be to replace that y with this notation, f inverse of x. And that's going to be equal to x plus 6 all over 2. And this right here is what f inverse of x is. X plus 6 all divided by 2. Okay. All right, now problem number 18. Here, this is where we use our graphing calculator to do this particular problem here. In number 18, you are to use your graphing calculator to make a graph of y equal 2x squared plus 4x minus 3. Okay, so here's my graphing calculator. Clear this junk out. And you're going to first enter this equation by pressing the y equal to button at the top. Now, if your plot is on like mine is, I'm going to use my up arrow key and press enter to clear it out. Otherwise, it's not going to work for you. So you have to use your up arrow key to go to plot 1 or 2 or 3 if it's on, if it's highlighted, and then hit enter to turn it off. Okay? So now for y1, in y1, I'm going to enter this equation, the 2x squared plus 4x minus 3. So I start off by pressing the number 2, and then xt theta n for your x, and then x squared for the exponent of 2, plus 4, and then xt theta for the x, minus 3. Okay? Now to get the graph, what I would do is press this button that says zoom, press the zoom key, and then select number 6 for the standard window. And that is the graph of the equation y equals 2x squared plus 4x minus 3. It's actually a parabola. Now that's part A. Now part B is to find the two x-intercepts of the function to the nearest hundred, or to two decimal places. So we're going to find out where this parabola crosses the x-axis. Those are your two x-intercepts here. And to do that, we're going to do second and trace. Press the second key, and then you're going to press trace. Now, we're finding the x-intercept. That means we're finding the zeros of that function. So we need to select menu item number 2 under the calculate menu. So I'm going to go down to number 2 and press enter. Now, you're going to get something that says left bound. In this case here, you want to use your left arrow key and place the blinking cursor above that first x-intercept. Somewhere above the first x-intercept is where that blinking cursor needs to be. And then you're going to press enter. And then for right bound, you're going to use your right arrow key to put the blinking cursor below that first x-intercept. And then press enter. And then after guess, you want to go ahead and press enter. And that will give you one of your x-intercepts here, which is in this case, negative 2.58, if we were to round that off to two decimal places. So negative 2.58 is one of your x-intercepts. The other x-intercept is over here. And we're going to go through that same thing. Second and trace, and select menu item number 2, which is a 0. That's the other x-intercept. Now this time, for left bound, we want the cursor below and then above. So this time I'm going to use my right arrow key. I want that cursor below that second x-intercept. So here it's going to be below that second x-intercept, and then we're going to press enter. For right bound, I want the cursor above that x-intercept, like this, and then press enter. And then after guess, go ahead and press enter. There's your other x-intercept. To two decimal places, that will be 0.58. Okay. Now part C is finding the coordinates of the point where the minimum occurs. And we're going to round that off to two decimal places here. The minimum is going to be the lowest point on the graph. So in this case here, I need to do second and trace for the calculate menu. And here I'm going to select menu item number 3 because I'm looking for the minimum. And then press enter. Now for left bound, I want the cursor on the left-hand side of the lowest point on the graph. So I'm going to position the cursor on the left-hand side of the lowest point on the graph as you see here. Then I'm going to press enter. Then right bound, I'm going to use my right arrow key to position the cursor on the right side of the lowest point of the graph. And then press enter. After guess, go ahead and press enter. This will be your minimum. And in this case, that x, I'm going to say that two decimal places, negative 1.00, and the y is negative 5. For the minimum, you must write down both the x and the y coordinates here. Negative 1.00, negative 5. Now part D says, additionally, make a graph of y equal x minus 1. Additionally, make a graph of y equal x minus 1. So I'm going to go to y equal 2. I'm going to leave y1. Then I'm going to go down to y2. That equation in y1 stays there. But in y2, I'm going to put in x minus 1. So xc theta for the x minus 1. And again, we can, if you want, you can go ahead and press graph. You'll see that it draws in the line, the graph of the line y equal x minus 1. That's part D. Now part E is finding the coordinates of the 2 points where the line intersects the curve. So I want to know the point of intersection here and the point of intersection up here. Let's start with this point of intersection right here. I'm going to do second and trace. This time, I'm going to select menu item number 5, which is intersect. Okay, press enter. Now, what I'm going to do here is use my left arrow key to position that cursor on top of that point of intersection as close as I can. So you want that cursor as close as you can to that point of intersection. Then I'm going to press enter 1, 2, 3 times. That will be my point of intersection right there. And it's the ordered pair -2, -3. Okay. Now for the other point of intersection, it might be hard to see, but it's up here somewhere. Okay. So second and trace, and then number 5 for intersect. I'm going to put that blinking cursor as close as I can to that point of intersection, like this. And then I'm going to press enter 1, 2, 3 times. So there's my other point of intersection. 0.5 and -0.5. 0.5, -0.5. Okay. So all of that represents problem number 18, just using that graphing calculator. And there was a calculator activity that has problems similar to that. So make sure that you are familiar with how to use that graphing calculator to do this particular type of problem. All right, problem number 19 is sketching the graph of the parabola f of x is equal to x squared plus 4x minus 5. And you're going to follow these steps. Part A, you're going to find the y-intercept. When you find the y-intercept, you always let x equal 0 here. So, I just say here, let x equal 0. By substituting 0 in for x in the f of x function, I'm going to have 0 squared plus 4 times 0 minus 5. Now if I simplify that, 0 squared is 0, 4 times 0 is 0, and 0 plus 0 minus 5 will end up being -5. So here I'm going to have -5 for the y-intercept, or the ordered pair 0, -5, as I should say, because that's the point where the parabola will be crossing the y-axis. Part B is finding the x-intercepts. Anytime you want to know what the x-intercepts are in a parabola, you take your function f of x, set it equal to 0. So I'm going to take that x squared plus 4x minus 5 and set that equal to 0. And then we're going to solve for x. Well, it's a quadratic. I can factor that into 2 binomials here. Break the x squared up as x and x. The factors of -5, that will give me 4x, so I have to be 5 and 1. But the middle term is a plus, so the larger of the 2 factors will take the sign of the middle term. The 5 will be plus, the 1 will be minus. So I got x plus 5 times x minus 1 equal to 0. And then we're going to set each binomial factor equal to 0. So here I'm going to have x plus 5 equal to 0, x minus 1 equal to 0. Each one of those I'm going to solve for x. So for the x plus 5 equal to 0, that means x equal -5. And then for the x minus 1 equal to 0, that means x equal 1. So -5 and 1 are the 2 x-intercepts. That means those are the points where the graph of that parabola will be crossing the x-axis at -5 and 1. Now part C is finding the coordinates of the vertex. Now, we're not going to worry about that completing the square part. We're just going to use the x equal -b over 2a. to find for the x-coordinate of that vertex. And then we'll substitute that x value into f of x to find the y-coordinate of the vertex. In this case here, your a is the coefficient of x squared, that's the understood 1. The b is the coefficient of x, that's your 4. I'm getting that from up here. That's the understood 1 is the coefficient of x squared. The 4 is the coefficient of x. And then we use that x equal negative b over 2a to find the x-coordinate of that vertex. So here your b is 4, so I'm going to have a negative 4 divided by 2 times a, which is 1. So here, negative 4 in the numerator. 2 times 1 will be 2. Negative 4 divided by 2 will be negative 2. So the x-coordinate of that vertex will be negative 2. Now to find the y-coordinate of the vertex, I need to take that negative 2 and substitute it for x in this f of x function up here. So here f of negative 2 will be negative 2 and that's squared plus 4 times negative 2 minus 5. So here negative 2 and we squared will be positive 4. And then 4 times the negative 2 will be minus 8, then minus 5. Well, 4 minus 8 will be negative 4. Negative 4 minus 5 will be negative 9. That will be the y-coordinate of the vertex. So the ordered pair, negative 2, negative 9, would be the vertex for this particular parabola. And then part D, we're going to take all that information and sketch the graph of the parabola. Okay. So the first thing I'm going to do here is plot the vertex, which is in this case negative 2, negative 9. To the left 2 and down 9. That's way down here. Now the axis of symmetry, I didn't ask for that. If you don't know it, the axis of symmetry is always going to be that vertical dotted line going through the vertex and the x-axis. In this case, it's actually going to be x equal negative 2, okay? Because the axis of symmetry is always going to come from x being equal to the x-coordinate of the vertex, which is x equal negative 2. So this graph of that axis of symmetry is x equal negative 2. I have a y-intercept of negative 5. So I'm going to go down 5 on the y-axis and draw that point in. My x-intercepts are at negative 5 and 1. So at negative 5, I'm going to draw a point on the x-axis, and at positive 1, I'm going to draw another point on the x-axis. Now, to get another point that will make this a smooth curve, I'm going to check the distance from this y-intercept to this axis of symmetry. That's 2 places to the right. So the other point on this side has to be 2 places to the left. So it's going to end up right here with the same y-coordinate. And now connect those dots. And this will be the graph of that parabola, f of x equal to x squared plus 4x minus 5. Okay. So that is all of problem number 19 here. All right, problem number 20. Here you're going to use synthetic division and the remainder theorem to evaluate the function f of x equal to x cubed minus 2x squared minus 29x minus 42 for x equal negative 5. In this case here, that x equal negative 5, when we use synthetic division, that x equal negative 5, that will represent the divisor. Now in the f of x, there are no missing terms here. We got x cubed, x squared, the x, and the constant, so we can write down their numerical coefficients. So for the x cubed, that coefficient will be 1. The x squared has a coefficient of -2. The x has a coefficient of -29. -42 is your constant. You have to forgive me for that line being a little bit lopsided. Here I'm going to bring down the 1, which is your leading coefficient in the bottom row. Then I'm going to multiply that 1 times the divisor. So -5 times 1 would be -5. That goes underneath the -2. And then I'm going to add -2 and -5 together. I'll get -7. And then repeat this until all the columns are filled. We're going to do -7 times -5. That'd be 35. Add -29 and 35 together, you're going to get 6. And then -5 times 6 will be -30. Add -42 and -30 together, you're going to get -72. Now, the last number in the last row, and notice I put a box there, that's your remainder. And not only that, that would represent the value of this function when x is equal to -5. So f of -5 equals -72. F of -5 equals -72. And that's how we use synthetic division and the remainder theorem to evaluate a function at a given x value. All right, now number 21. Use the factor theorem and synthetic division to find the zeros of the function f of x equal to x cubed plus 8x squared plus 11x minus 20, given that -4 is a zero of the function. Well, if -4 is a zero of the function, that means f of -4 has to be equal to 0. And that's going to mean that x minus that constant, which is in this case x minus the -4, or simply x plus 4, is a factor of the function f of x. So we know one of the factors is x plus 4. Now we need to know what the other factor is going to be. Well, we can find that out by using synthetic division. Here, that -4 will be my divisor. And if you look at your f of x function, there are no missing terms here. We got x cubed, x squared, the x, and the constant term. So we can go ahead and write their numerical coefficients. So for the x cubed, it's going to be 1. X squared has a coefficient of 8. The x has a coefficient of 11. -20 is the constant term. So now we're going to bring down the 1, which is my leading coefficient in the bottom row. And then I'm going to multiply that number times the divisor. So -4 times 1 will be -4. Add 8 and -4 together, you're going to get 4. And then -4 times 4 will be -16. Add 11 and -16 together, you're going to get -5. And then finally, -4 times -5 will be 20. Add -20 and 20 together, you're going to get 0. So here, I would expect to get a 0 remainder because the -4 is a 0 of that function. Since x plus 4 is a factor, here's the other factor right here. The 1, 4, and -5, that's the other factor for this particular function. Okay, so here's how I write that factor, the other factor. The -5 is the constant term. The number in front of that would be the coefficient of x. The number in front of that would be the coefficient of x squared. So here, this is the other factor, 1x squared, or just x squared, plus 4x minus 5. And I'm going to set that equal to 0. Now the x squared plus 4x minus 5, I can factor that into 2 binomials here. I'm going to bring down the x plus 4. I can factor that by breaking up x squared as x and x. The factors of a negative 5 that would give me 4x will have to be 5 and 1. And the 5 will have to have a plus sign because the middle term is plus. Keep in mind that the larger of the two factors takes the sign of the middle term. The 1 has to be minus. So I get x plus 4 times x plus 5 times x minus 1 equal to 0. So this is factored completely. Now we're going to set each individual binomial factor to be equal to 0. So this means x plus 4 equals 0, x plus 5 equals 0, x minus 1 equals 0. Each one of those we're going to solve for x. So for the x plus 4 equal to 0, if I subtract 4, I'm going to get x equal negative 4. For the x plus 5 equals 0, subtract 5, you get x equal negative 5. And then for the x minus 1 equal to 0, add 1, you're going to get x equal 1. So the zeros of that polynomial function will be negative 4, negative 5, and 1. Okay. So that's how we use the factor theorem and synthetic division to find all the zeros of that function. And we were given that negative 4 is a zero of the function. And these two, negative 5 and 1, are the other two zeros of that function. Okay, that's problem number 21. All right, number 22. Here we're going to be using our calculator, which helps us do the Gauss-Jordan elimination to solve this system. We got 3x minus 4y equal 11, 2x plus 3y equal negative 4. Here's what you're going to have to do here. On the exam, I would expect you to write this as a augmented matrix here. The first column is always the x coefficients, the second column is the y coefficient, and your constant term is on the right side of the equal sign. That vertical bar represents the equal sign. So here, your x column will have to be those x coefficients here, 3 and 2. The y, the coefficients are negative 4 and 3. The constants are 11, negative 4. And they have to be written in this order. Okay? Now, the next thing we're going to do here is use our calculator to come up with x and y. Okay. First thing we need to do here is press second, and then you're going to press x to the negative 1. Okay? Now I'm going to store this in matrix A. So I need to go to edit, because I'm putting in a new matrix, and I'm going to put it in matrix A right here. So I'm selecting number 1. Now, I need to find out how many rows and how many columns are. These two numbers here represent the number of rows and columns here. In this case, I have 2 rows and then 3 columns. So this first number, I'm going to enter a number 2, because I need 2 rows. And then there are 3 columns, so I'm going to enter number 3, because I need 3 columns. Now I'm going to enter each element row by row, or each number row by row, starting with that first row, 3, negative 4, and 11. So I'm going to start with a 3 and then enter, then go to negative 4, enter, then 11, enter. It's going to take me to the second row where I need to enter the second row numbers, 2, enter, 3, enter, negative 4, and make sure you do press enter after the very last number in the last row and last column. And then I'm going to quit by pressing second and mode to get out of it. Now the next step is to press second and x to the negative 1. I'm going to go over to the math menu by using my right arrow key, and then I'm going to go down, use my down arrow key to find this menu item that says RREF. That is Reduced Row Echelon Form, RREF. I'm going to select that by pressing enter. Now I'm going to pull up that matrix that I saved. I saved it in matrix A, so I'm going to do second, x to the negative 1. Then under the names menu, I saved it in A, so I'm going to select number 1 for A. because that's where I saved that matrix. Then press enter. Press the right parentheses if you like, then press enter. So this is what you need to copy down on the paper. In this case here, we got the 1, 0 with a vertical bar, 0, 1, and then 1, negative 2. That would be the reduced row echelon form of that matrix here. And keep in mind the last two numbers, well, the two numbers in the last column, I should say, represent what x and y is. So here, that first number is your x, which is 1. The second number is your y, negative 2. So the ordered pair, 1, negative 2, would be the solution to that system of linear equations here. So this is all you have to do here. Need to write this, put this as an augmented matrix, write that down, write down the output that you got, and then tell me what x and y are equal to, either as this or as an ordered pair. Number 23. We're going to use Cramer's rule to solve this system. 4x plus 3y equal 15, 2x minus 5y equal 1. If you recall, we need 3 matrices, one for D, one for D sub x, and the other one will be for D sub y. Okay, the D matrix always has the x and the y coefficients there. And you want to make sure that these equations are in standard form, where the x and the y on the left side, the constants on the right side. Okay, so here the x column would be these x coefficients here, 4 and 2, in that order. The y coefficients in the y column will be 3 and negative 5. That goes here. The D sub x, you can have the coefficients in the first column instead of the x's, and you'll still have the y coefficients. So my y coefficients, I'm going to have the 3, negative 5. I'll go ahead and copy those over. My constant terms are right here, the 15 and the 1. And then D sub y. The x coefficients will be in the first column, but instead of the y coefficients, the constant terms will be put in place of that. Your x columns, or x coefficients, are 4, 2. The constant terms are 15 and 1. And now we're going to find the determinants for all 3 of them, starting with the D. If I do this diagonal first, take its product, 4 times negative 5, I'm going to get negative 20, minus the product of this diagonal, 2 times 3, that'll be 6. And then negative 20 minus 6 will be negative 26. And then for the D sub x, if I do 15 times negative 5, that's a negative 75, minus 1 times 3, which is 3. Negative 75 minus 3 would be negative 78. And then for the D sub y, if I do 4 times 1, that will be 4, minus 2 times 15 will be 30. Now 4 minus 30 will end up being negative 26. So I have D, D sub x, and D sub y. The next step will be to find out what x and y is. Your x is always going to be D sub x divided by D. The y will be D sub y divided by D. So to find out what x is, D sub x divided by D, D sub x is negative 78 divided by D sub, well, just D, negative 26. Negative 78 divided by 26 would be 3. So x will be equal to 3. D sub y, for the y, D sub y is negative 26. D is still negative 26. Negative 26 divided by negative 26 will be 1. So y will be equal to 1. So The ordered pair for this system of equations is 3, 1. Okay? So that's how we use Cramer's rule to solve this system of linear equations. Okay, number 24. Here we're going to evaluate the determinant 3, negative 2, 1, 2, 4, 3, negative 1, 5, 1. And when I say do not use the calculator, that means do not use that DET menu item, like the one here for the math, and then, second x to the negative 1, go to math. That DET item, don't use that. You're going to do that by hand. The way we do that is we rewrite the first two columns of this particular matrix here. So here, I'm going to rewrite 3, 2, negative 1. And then the second column, negative 2, 4, and 5. I'm going to rewrite that. Negative 2, 4, and 5. Now here's how we find that determinant. That's going to be equal to this. We're going to take the product of this diagonal going from the upper left to the lower right. And then add the product of that diagonal and add the product of this diagonal from the upper left to the lower right. Starting with this diagonal. If I do 3 times 4, that will be 12. 12 times 1 is 12. And then plus the product of this diagonal, negative 2, 3, negative 1. In this case, negative 2 times 3 is negative 6. Negative 6 times that negative 1 is 6. And then plus the product of this diagonal, 1, 2, and 5. 1 times 2 is 2. 2 times 5 will be 10. And then we're going to subtract the product of this diagonal going from the upper left to the lower left to the upper right, minus the product of this diagonal, and minus the product of that diagonal, each going from the lower left to the upper right. Let's start with this one going in this direction, the negative 1, 4, and 1. And you can put a minus sign here to make sure that you're going to subtract. Negative 1 times 4 would be negative 4, times 1 would be negative 4. So I have minus negative 4, and then minus the product of this diagonal here, 5, 3, and 3. 5 times 3 would be 15. 15 times 3 would be 45. And then minus the product of that diagonal here, 1, 2, and negative 2. 1 times 2 would be 2. 2 times negative 2 would be negative 4. So we've got minus a negative 4 here. Now, if you want to, you can clean this up or type all of that into the calculator. Okay, I'm going to clean this up a bit. Have 12 plus 6 plus 10 minus a negative 4 will be plus 4 minus 45, and minus a negative 4 will be plus 4. So if I was to enter this as 12 plus 6 plus 10 plus 4 minus 45 plus 4, I'm going to end up with negative 9. So the determinant of that 3 by 3 matrix would be negative 9. I left out the negative. Okay. So that's how we find the determinant of a 3 by 3 matrix. All right, number 25. Here we're going to find log to the base 3 of 17 using the change of base property. And we're going to round the answer to the nearest 100. So in this case here, when we use the change of base property, we can use either common logarithms or natural logarithms. Here I'm going to use natural logarithms here. I'm going to do ln of what I'm taking the log of, 17, divided by the natural log of the subscript, which is 3. Okay. So if I was to enter that in the calculator, I press the LN key and then type in 17. You want to close the parentheses around the 17. Otherwise, you're going to get a wrong answer because you only want the natural log of 17. That's going to be divided by LN, press the LN key, and then 3, close parentheses, and then hit enter. Okay, here we're going to round to the nearest hundredth. That means to 2 decimal places. This will be 2.58 because this is a 7. Next to it is an 8. 8 is bigger than 5, so we increase the 7 to an 8. So it will be approximately 2.58 for log to the base 3 of 17. Okay, that's problem number 25. All right, number 26, we're going to expand the logarithm as far as we possibly can using a combination of the product, the quotient, and the power rules. Should be familiar with that. So here we got the log of p to the 9th, and this is a times sign, the 4th root of n divided by m to the 5th power. Well, right off the top, I see we got a numerator and a denominator. That tells me I have a log of the quotient. That means I need to apply the quotient rule by expanding that as the log of the numerator, which is p to the 9th times the 4th root of n, minus the log of the denominator, m to the 5th. Now for this first term right here, there's a times sign in between p to the 9th and the 4th root of n. That tells me I have the log of the product. I need to apply the product rule by expanding that as the sum of their individual logarithms. So here, I'm going to expand that as the log of p to the 9th plus the log of the 4th root of n. Then bring down minus log of m to the 5th. Now I'm going to bring this down before I do anything. Log of p to the 9th. That 4th root of n, I need to write that as a term in exponential form, okay? That n has an exponent of 1. That will be the numerator. This 4, which is my index, will be the denominator. So the 4th root of n will be n to the 1/4 power, and then minus log of m to the 5th. Okay? And now each term I'm going to apply the power rule by bringing the exponent in front of each logarithm. So for log of p to the 9th, I'm going to pull the 9 in front, so it'll be 9 times log of p plus for log of n to the 1/4, that 1/4 will go in front of log of n, and then minus log of n to the 5th, that 5 will go in front of the log of m. So this logarithm expanded as far as I possibly can would be 9 times the log of p plus 1/4 log of n minus 5 log of m. Okay. Number 27 is a logarithmic equation. So here you're going to solve log to the base a of x plus 4 plus log to the base a of 6 equaling to log to the base a of 42. And you're going to have to check your proposed solutions. So it is important that you do the check. So here we got log to the base a of x plus 4 in parentheses plus log to the base a of 6 equaling to log to the base a of 42. Now notice I have logarithms on both sides, so I know I'm going to use the one-to-one property. But the first thing I need to do here is condense the left side as a single logarithm. Notice I have a plus sign in between the logarithm. That tells me I have the sum of their individual logarithms. I can condense that as the log of the product. So condensing that, it will be log to the base a of Now I'm going to put the 6 in front of the x plus 4. So I got log to the base a of 6 times the quantity x plus 4. And that's equal to log to the base a of 42. This is already a single logarithm. Now this is where the one-to-one property comes in. Because I have log to the same base on both sides, log of base a on both sides. That means by the one-to-one property, I can take this expression of 6 times the quantity x plus 4, set that equal to that numerical term right there, 42. So here I got the equation 6 times the quantity x plus 4 equal to 42. And then I'm going to solve for x. Well, distribute the 6 over the x plus 4, you're going to get 6x plus 24. 6 times x is 6x. 6 times 4 is 24, equal 42. And to solve for x, first of all, I need to move the 24 over by subtracting 24 on both sides. So I got 6x is equal to 18. And then divide by 6. X will be equal to 3. Now that's my proposed solution. In this case, I need to do the check. So here's how I do the check here. And you have to do the check, otherwise you'll be counted off for that if you fail to do so. Log to the base a, replace the x with 3, so it'll be 3 plus 4, plus log to the base a of 6, equaling to log to the base a of 42. Now 3 plus 4 is 7, so log to the base a of 7 plus log to the base a of 6 equal log to the base a of 42. Now on the left side, the sum of their individual logarithms condenses as a log of the product. So this will be log to the base a of 7 times 6, equaling to log to the base a of 42. And if I multiply the 7 times 6, I'm going to get log to the base a of 42. And that's exactly the same as log to the base a of 42. So that checks. So here x equal 3 is the solution to that logarithmic equation. Okay? So that's problem number 27, where we're using the one-to-one property. All right, number 28. Here we're going to solve the logarithmic equation log to the base 6 of the quantity x plus 5 minus log to the base 6 of 7 equaling to 2. Now notice only the logarithm is on one side. Okay, it's not on the right side, so we have to use the definition of a logarithm by converting it into its equivalent exponential form. But first, we need to condense the left side as a single logarithm. Here I got a minus sign. That tells me I have a difference of their individual logarithms, so I need to apply the quotient rule. Write that as the log of the quotient. So it'll be log to the base 6 of x plus 5 over 7. The x plus 5 will be the numerator. The 7 will be in your denominator. So I got log to the base 6 of x plus 5 divided by 7, and that's equal to 2. Now I'm going to take that and convert it into its equivalent exponential form, since I have the log on only one side of this equation. So here we're going to have 6, which is a subscript of the log. The 2 will be the exponent for the 6, so it'll be 6 squared equal to what's immediately after the log. So I got 6 to the second, or 6 squared, equal to x plus 5 divided by 7. And then the next step would be to simplify this equation. If I square the 6, that's 6 times 6, that would be 36, is equal to x plus 5 divided by 7. Now I got that 7 in the denominator, so to get rid of it, I need to multiply both sides of this equation by 7. Because I'm dividing by 7, The opposite of that would be to multiply both sides by 7. Now, when I do 7 times 36, I'm going to get 252. And that's equal to, and these 7s divide out, I'll be left with x plus 5. And that's equal to 252. And to solve for x, I need to subtract 5 on both sides. So that means x is equal to 247. Now to do the check, I take the original equation and replace the x with that 247. So it'll be log to the base 6 of 247 plus 5 minus log to the base 6 of 7 equal to 2. Now if I add 247 and 5 together, I'll get 252. So log to the base 6 of 252 minus log to the base 6 of 7 is equal to 2. Now here I got the difference of their individual logarithms. I can condense that as a log of the quotient. So it'll be log to the base 6 of 252 divided by 7. That should equal to 2. If I take that 252, divide that by 7, that will end up being 36. So log to the base 6 of 36 should equal to 2. Then convert this into its equivalent exponential form. 6 to the second equals 36. Whoops. 6 to the second equal 36. If you square the 6, you will get 36, which is the same. So x equal 247 is the solution to that logarithmic equation. Now, keep in mind, on all your logarithmic equations, you must do the check. And I will be expecting to see that check on my final exam, or otherwise you'll be counted off. Now, number 29. We got 10 to the x minus 7 equal 18. We're going to solve this exponential equation and round to the nearest hundredth, meaning to 2 decimal places. In this case here, we got a base of 10 in our exponential equation. Now, normally you would take the natural log on both sides, but with a base of 10, we're going to take the log on both sides, log. You're going to take the log on both sides of this equation. Now, for log of 10 to the x minus 7, there's a property that states, for inverse properties of logarithms, if you have log of 10 to whatever your exponent is, it's going to be that exponent because log to the base 10 and the base 10 itself are inverses. So log of 10 to the x minus 7 would be x minus 7. And that's equal to the log of 18. And now we need to solve this equation for x. We're subtracting 7. We need to add 7 on both sides. So this will be x is equal to, let's see, I'm going to put the 7 in front of log of 18. And you'll see why I did that. I mean, you can put it after, but you want to make sure that when you type in the calculator, it is correct. So when I do it this way, if I do 7 plus, and then press the log key, and then 18, close parentheses, you'll get that number, 8.255272505. But to the nearest hundred, or to 2 decimal places, that will be approximately 8.26. Now, if you did it the other way, by doing this, typing in the log and then 18, make sure you close the parentheses around the 18. Otherwise, you're going to get a wrong answer because you only want the log of 18. And then that's going to be added to 7. Okay? And you'll still get approximately 8.26. Okay? And finally, problem number 30. How long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% interest compounded continuously. You're going to round your answer to the nearest tenth. So here we're looking at a principal of $5,000. We want it to be at $7,500. That's what A is going to be equal to. Your interest rate was 7%. Now, 7% as a decimal, you take 7, divide that by 100, that will give you the decimal interest rate, 0.07. And it's compounded continuously, so we must use this formula. A is equal to P times e to the RT. And then we're going to substitute the A, the P, and the R in that compound interest formula. So your A is at $7,500, and that's equal to P, that'd be 5,000, times e to the R, 0.07, and then T is what we're trying to find. So this is what your exponential equation looks like. And now we're going to get the exponential part by itself, that e to the 0.07t. Is being multiplied by the 5,000, so we're going to have to first divide both sides by 5,000. So here I'm going to have the e to the 0.07t, and if I do 7,500 divided by 5,000, I'm going to get 1.5. So I have 1.5 is equal to e to the 0.07t. Now, since e and the natural log are inverses of each other, I'm going to be taking the natural logarithm on both sides. Here I'm taking the ln on both sides. So I get ln of 1.5. Now, ln and e are inverses, so if I have ln of e to whatever my exponent is, it's going to be that exponent. So ln of 0.07t is going to be 0.07t. And to get t by itself, I'm multiplying it by 0.07, so I need to divide both sides by 0.07. So here t will be equal to, well, this is the actual value. I'll rewrite that. But for the approximate value, which is what I'm looking for, we need to use our calculator. So here we're going to have ln 1.5, close parentheses, divided by 0.07, and then hit enter. And to one decimal place, that would be approximately 5.8. So this is going to take approximately 5.8 years for a $5,000 investment to grow to $7,500 at 7% compounded continuously. Okay? So here, this is basically what you will see on the final exam, or what you can expect to have on your final exam, which is going to be given on the date and the time that is indicated on Canvas that I mentioned, and I did mention it in class when your final exam will be, so be mindful of that. If you have any questions, please feel free to email me or call me if you have any questions or need additional assistance with this. Thank you very much, and best of luck with you on the final exam.